Okay, so I hope you're really holding up with the previous session. And now we have a question here. Look at this question, and I really wanted to think over and find out whether you have seen this question before, quite recently. All right, an aircraft cruising at 10,000 feet is approaching towards a VOR. It is required to descend at 800 feet per minute at a ground speed of 120 knots so that the aircraft would be 2,000 feet overhead affects 10 nautical miles from the station. At what distance from the VOR must the descent be initiated? Now, this question was actually asked for your theory, the semester exam theory this time. And this question kind of was held up towards the beginning, and you had a barrage of other questions after that. You probably might have thought that who's going to do this? Now, this question kind of talks about VOR, and for this particular semester exam, I know VOR was not as in the syllabus, not part of your exam, but and that for that reason, at least a few of you must have skipped the question, thinking that it has come from a different topic. But unfortunately, even though we have this VOR particularly mentioned here, this question has nothing to do with the VOR itself. It's just a radio aid. All right, perfect. Now let's look at this question. Now you are actually cruising at 10,000 feet and you're approaching towards a VOR. So we have kind of looked into VOR in detail in your radio navigation, but as I told you, this question has nothing to do with that. All right, so if you are kind of a bit aware of a basic trigonometry or basic triangles, then that's definitely going to help you with this question. Okay, so you are cruising at 10,000 feet, you're approaching towards a VOR. So let's put that particular data into picture right here. All right, so we have this straight here. Let's draw the VOR. So let me kind of draw the VOR straight here. You know, I'm a bit of, you know, kind of looking into a bit of perfection. I kind of draw things as well. So I know it might take some time, but don't worry, you don't necessarily have to draw VOR like this, but this is how it looks like, right? And this is the VOR straight here, and you are actually cruising at, say, 10,000 feet. Let's draw the cruising altitude straight here at 10,000 feet. All right, now let me draw the aircraft. Perfect. Now you're approaching a VOR, which means you're tracking towards the VOR. It is required to descend at 8,000 feet per minute at a ground speed of 120 knots. So you are now required to descend at a particular feet per minute. That's given as 800 feet per minute, which is straight here. All right. So that the aircraft would be 2,000 feet overhead affects 10 nautical miles from the station. So there is a fix which is kind of 10 nautical miles from the station. Let's put that here. So by station, what we mean is the VOR. It could be NDB, it could be any of the radio aids here. So the question kind of says that there is a fix which is 10 nautical miles from the station, right? From the VOR station. All right, this fix could be a mountain, it could be a larger stadium, it could be a bigger lake, or it could even be another radio aid. All right, so let's kind of make this a tower here straight. Now the question says that you're required to descend at a particular feet per minute, which is the rate of descent, and at a particular ground speed, which is the true ground speed of the aircraft, in such a way that while you reach overhead the fix, so possibly let me use a different color. All right, yeah, so while the aircraft reaches overhead this particular fix that we have, the aircraft has to be at a height of 2,000 feet. So that's kind of measured again from the ground. So this is the ground level, and the aircraft is 2,000 feet above the fix. All right, perfect. So that's it. So don't really get confused with the height of the fix because it's nothing to do with this question. So basically, as you are overhead the fix, you're 2,000 feet above the ground level. Perfect. That's it. Now, at what distance from the VOR must the descent be initiated at 800 feet per minute at 120 knots of true ground speed, so that you would end up 2,000 feet overhead this fix, which is 10 nautical miles from the VOR station? That's exactly what is asked in the question. All right, perfect. Now let's kind of disintegrate this whole session. So you need to actually descend at 800 feet per minute at a ground speed, at a true ground speed of 200 knots. So how far would you think you would travel at a rate of 800 feet per minute with a ground speed of 120 knots? All right, perfect. Having this particular understanding in mind, I'll give you 2 full minutes. Take 2 full minutes and think about it on how can you really find the distance at which you need to kind of start the distance. Let me kind of mark that here. You're asked to find out the distance from the VOR station. So what distance from the VOR must the descent be initiated so that you can actually descend at 800 feet per minute at a true ground speed of 120 knots and you still reach overhead of fix that is 10 nautical miles from the VOR station at 2000 feet, right? Try finding it out and I will see you on the other end, right? There are a few of you who have kind of dropped the answer correct, and you see how simple this question is. There is no concept of VOR here, and that kind of really fumbled your mind, and most of you kind of switch this question out. Right here, you're asked to find out the distance from the VOR station. Now let's see that right here. So before we look into the details of this particular question, I would like to draw your attention to a particular figure down here. Now, most training aircraft, not all, have their ground speeds around 120 knots, right? So a ground speed of 120 knots, and what you need to understand is an aircraft would travel 120 nautical miles every hour. That is the meaning of you traveling at 120 knots, right? Now this means that every minute, what is going to be the distance traveled? It's divided by 60, which is 2 nautical miles. This is quite a relatable figure, especially when you do a training and your instructor kind of asks you, hey, you're traveling at 120 knots ground speed, and how far do you think your aircraft would cover in 5 nautical miles? So in 5 minutes, sorry. And every minute, 2 nautical miles. So in 5 minutes, it's going to be 2 into 5, which is 10 nautical miles. Kind of a very rough figure. If not 10 nautical miles, it's definitely going to be around 10 nautical miles with respect to the wind as well, right? So having this particular idea in mind, remember in this particular question, you're kind of descending at 800 feet per minute. And what you need to understand is at this particular feet per minute, you need to descend from 1000 feet to 2000 feet above the fix, which means you are kind of making a descent of 8,000 feet. I'm going a bit quick here because most of you are giving me the right answer. And because I kind of understand that you realized this is not a VOR specific question, right? Perfect. Now, 8,000 feet at 800 feet per minute. So 8,000 feet at the rate of a descent 800 feet per minute. Pretty obvious that you're going to take 10 minutes to cover that particular height, right? Now you come back to this particular value here. You are having a true ground speed of 120 knots. And you're traveling for 10 minutes. How far do you think the aircraft is going to travel? Your distance traveled is going to be 20 nautical miles. Pretty obvious, right? Which means you need to start your descent 20 nautical miles before the fix for you to actually reach overhead the fix at 2000 feet at 800 feet per minute with 120 knots of ground speed, right? Now, descent and ground speed has a particular connection. You must have studied this in your ILS, where you calculate the rate of descent. And we know that especially for a very commonly used 3-degree glide slope, we have the rate of descent, which is 5 times your ground speed. So they have kind of an interrelationship there. So having understood the fact that you cover a distance of 20 nautical miles while you go through this descent, it's pretty obvious that you need to be 20 nautical miles away from this particular fix. All right. Now this makes you 30 nautical miles away from the VOR. You see how the question kind of unfolds pretty much quick, nothing particularly related to VOR here. So go through this question once again. So you have 20 nautical miles from the fix. The fix is already 10 nautical miles from the VOR, which means you need to start a descent 30 nautical miles from the VOR. Perfect. Now, why this question? I thought of putting this question primarily because not the question is difficult. Most of you must have actually judged the answer primarily, but there are a few people who kind of skipped it. 2 reasons. Number 1, they thought something connected to VOR, and VOR was not part of your first semester exam. Number 2, this particular question was followed by a barrage of other questions, and they kind of really fumbled and thought, why would someone do this and waste time? But you have more easier, simpler questions coming up. This is one of the most simplest actually, right? So no worries, this is how you learn. So if you have kind of understood this, we will now quickly go into a particular question concerning a rate of descent. Now, in this particular question, I wanted to focus on a couple of values. One is 800 feet per minute, and you need to know what the meaning of that is. 120 knots, which I kind of explained. So scan through this particular question, very simple. a very positive kind of a question. Let me know if you have doubts. Do drop in the chat and I'll definitely get back to you.